everyone, welcome to Sciencing with Abby. I am obviously Abby. I'm here with the Research Triangle Nanotechnology Network, or the RTNN, which is a partnership between NC State, UNC, and Duke. I represent NC State, go Pack. And we are partners to do really cool science to really small things, but more on that in a second. Today, we are going to do some really neat science experiments, but first, you guys are going to need to get some supplies. So I have a supply list out and ready for you. Feel free to pause this video if you want to go grab them. Ready, set, go. Okay, welcome back, y'all. So now that you guys have all of your supplies, I first want to talk about some safety. So when you are doing science experiments, it's always good to practice good safety. Now, I want to stress that all of these experiments are perfectly safe, but I want to make sure that if you're doing a science experiment, that you have a science buddy with you. So preferably an adult or a parent around. So please go grab that person to make sure that we are practicing science safely. I don't have another person to do science with, unfortunately, but I do have my friend Mr. Bill here, so he's going to act as my science buddy today. Before we dive into some science experiments, I want to go back and talk about this big word that I said earlier. So I mentioned that I was with the Research Triangle Nanotechnology Network, but what does that word nanotechnology mean? It's basically just a really big word for doing science to really small things. I want you to think about something that you've learned probably in your science classes. I want you to think about the 3 states of matter. So we know the 3. First one is solids. Solids keep their own shape. So if I were to take this carton of milk and put it in the pie dish, it's not just gonna randomly melt into a pile of goo to fit into the pie dish, right? That would be crazy. So we know that solids stay their own shape no matter where they are, and we can interact with them, right? I can make it into a hat if I want. Next, so that's first one is solids. Second one is liquids. Now, if I were to open the cap of this milk and pour it into this container, I can still interact with the liquid, right? But it's going to become the shape of its container. So other liquids are oil and water and soda and anything else that you can think of that you can pour into something else that will take the shape of its container. Now the third one is called gases. So I want you to take a really deep breath in and then let it out. What you just did, or what you just breathed in, was gas. It was air. We can't see air, but we know it's all around us. We can't interact with it. I can't poke an air molecule and know that it's there, but we know that air is made of molecules, just as liquids are made of molecules and solids are made of molecules. Now, if you haven't heard the word molecule before, molecules are basically like the Lego building blocks of everything in the universe. Everything is made of molecules, but molecules are too small for us to see with our eyes. So I can't look really hard and say, yep, there is one molecule right there. Our eyes just aren't good enough to do it. And that's why they're classified as nanotechnology. So too small for us to see with our eyes. But we're going to do some science experiments to see if we can do science with some of these molecules. Now, if you remember, the second state of matter that I mentioned was liquids. So you can pour liquids into things, you can interact with them, they take the shape of their container. And here, what I have is a liquid that you guys all know called milk. And milk is a really special kind of liquid because it's actually made of, among a lot of other things, it's made of 2 things, water and fat. But more on that later. I would actually like to talk about water for a second because water, you guys interact with it every day, but it's actually one of the coolest liquids out there, and I'm going to show you why. So for our first science experiment, I want you to take your paper towel or napkin or whatever you've got, lay it down, and you're gonna grab your penny and put it on top of your napkin. Now, what we're going to do is take our straw, and use a super sciencey straw capping mechanism technique. Pet me, just kidding. So if you have ever drank something out of straw, and you've noticed that you can cap the straw, you can like pull up the liquid in the straw, and then if you let it go, the liquid will fall out, right? And then sometimes, maybe if you're at a restaurant and you try and drink it upside down, like waterfall it into your mouth, your mom or dad might get mad, but it's all right. So that's the technique that we're gonna be using today. Instead of using something called a pipette, so if we were in a real science lab, we would be using this squishy plastic thing called a pipette that allows us to pick up a liquid and put it somewhere else. But I don't know about you guys, I don't have a mad science lab in my basement as much as I would love to have one of those. I don't. So we're going to use our super sciencey straw capping technique instead, which will work just fine. Now, before we do this, one more thing. I want you guys to think like scientists, right? Because we're doing science experiments here. I have a lab coat. It's all very official. So think like scientists for a second. And I want you to turn to your science buddy. Do you have your science buddy? Okay, turn to your science buddy, and I want you to predict what will happen if we slurp up some of the water using our super sciencey capping straw technique and put drops of water on the surface of the penny. So tell your super science buddy what you think is gonna happen. Okay, I whispered it, but you should actually probably say it out loud. Now, you might need some help with your science buddy on this one, but what I want you to do is grab some liquid using your straw capping technique, and I want you to put really small, slow drops onto the surface of the penny. This won't work if all of the liquid comes out all at the same time. You want to make sure it's coming out in drops. So here we go. Hopefully this will work. Let's see. That is pretty weird. Now, hopefully, if your science at your house is the same as my science at my house, which hopefully it is, you'll notice that the water didn't just fall off the sides of the penny. It almost created this dome on the surface. And it did this because of a really unique property that water has called surface tension. And what surface tension means is that the outside of the water, the surface here that kind of looks like it's creating this dome, is stronger than the inside of the water. So the outside wants to hold everything in because it's much stronger, and it doesn't want to let the insides spill out onto the rest of the napkin. But now I want to turn our attention back to milk here. So milk, as I said earlier, is made of two things. It's made of water and it's made of fat. So we just showed that water has this really cool thing called surface tension, right? The water, when we put drops of it on the surface of the penny, created that dome and it kept everything inside and it kept it from spilling over. So we know that milk is made of water, but it's also made of fat. And the cool thing about water and fat is that they classify as two different categories of molecules. So one category, I'm going to call it the blue category, is going to be our water here. And the other category, I'm going to call it red, is going to be our fat. And here we're going to use oil instead, because both fat and oil are both in the red category. And to help you guys see this a little bit better, I am going to add, and you're welcome to do this too, I'm going to add some blue food coloring to my water, just because it makes it a little bit more fun. Parents, this reminds me of when you put half and half or creamer in your coffee in the morning. I love how it makes that really cool pattern as it's swirling down. Now that we have our food coloring into our jar, I'm going to stir it around a little bit just to make sure it looks all nice and even. Now we're going to add our oil, which is the red category, to the water, which is the blue category of molecule. Now I want you to turn to your science buddy again and say what you think will happen when we add molecules of two different categories together. So, Mr. Bill, when we do this science experiment, I think what will happen is that the oil and the water will mix together. What do you think? Let's find out. Okay. So what happens when you quarantine by yourself? Okay, so I'm gonna open this oil and I want you guys to pour your oil into the water. Let's see what happens. Dun, 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 dun. All right, I'm ready for some science. What's happening? Is it mixing together? Not on my end. That's pretty weird. Maybe we just didn't mix it enough. So now I want you to take your cap, screw it onto your lid, make sure, science buddy, make sure it's screwed on nice and tight so we don't want any spills here. And I want you to shake it. All right, maybe this time. All right. That's pretty weird. The oil is still separating from the water. Even after we shook it really well, it's still separating into two parts. I want to tell you guys a secret. I knew that was going to happen the whole time. Tricked you. What happened here is that, remember how I said the water is our blue category of molecule, right? And I said our oil is our red category. When we mix together a blue category and a red category, they don't want to mix together. They immediately want to separate into two parts, which is all well and good, but how does this relate to milk, right? I mentioned that milk has both water, blue category, and fat, which is actually the red category. So let's see what kind of science we can do knowing those two things. I want you to take your milk and pour it into your container, just enough so that, almost running out there, just enough so that it covers the bottom of your dish or whatever you're deciding to use as your science receptacle. And it doesn't have to be anything exact, just enough so that it covers the bottom. And now, I want you to take your food coloring, as many colors as you want, and I want you to add little drops of food coloring onto the surface of your milk. And now something else that I want you guys to do, again, we're thinking like scientists, right? All very official, very sciencey. As we're thinking like scientists, I want you, as you're putting the drops of food coloring into your milk, to observe what is happening and describe it to your science buddy. So I'm going to take my blue, which is going to be for our friends over at UNC and Duke. I'm going to add some drops there. And then I'm going to take my red for all my friends over at NC State. I'm going to add some drops. Now I want you to look at the surface of your milk where you put the food coloring. Is it moving around? Sure, maybe a little bit, but for the most part, it's actually just staying where it is. Why do you think that is? So I want you to think back to our science experiment that we did with the penny, where we learned about surface tension, right? When we put the drops of water on the surface, it stayed there because the surface of the water of the water on the surface of the penny was stronger than the insides, right? And so, and I said earlier also that milk has water and fat in it. So when we dropped the food coloring on the surface of the milk, which is basically the surface of water, right? The food coloring doesn't want to move around because the surface of the water is keeping it all together. So another way to think about it is, let's say you grab a pair of ice skates and you lace them up and you decide, I am going to go ice skating in the driveway. Does it work? Can you do it? I don't know about you, but I can't ice skate in the driveway. You're not going to go anywhere. And your parents would be kind of mad that you scuffed up a good pair of ice skates. So you can't go ice skating in the driveway, much like the food coloring can't zoom across the surface of the milk because the water is keeping it all in one place. Now for my favorite part of this whole video, you're going to take your dish soap, and I like to put it into a little container. It just makes it a little bit easier. So you don't need very much at all. And I want you to take your Q-tip, dip it into your dish soap, and I want you to pause and think about two things. First, think about what you think will happen when we put the dish soap into the milk with the food coloring. So that's thought number one. Thought number two, I want you to think about when grown-ups tell you to wash your hands with soap and water. Have you ever thought about why you can't just run your hands underwater and that will clean them? Because we're about to find out. So I'm actually going to have all of y'all do this experiment first because I don't want to ruin the surprise. So go ahead, dip your Q-tip with your soap into your milk and let's see what happens. So I'm going to do it now too. Ta-da! Oh, that looks so cool. Man, I've done this experiment a lot and I still never get tired of that. As you're doing this experiment, science buddies, please take out your phone or your camera or whatever, and I want you to take pictures of these beautiful milk art creations that you're making, and I want you to either send them to me. I've got my email and I'll put it in the description as well, or you can tag us, tweet us at RTNN social, or just figure out a way to get those pictures to me because I really want to see what you guys are making. So now that you have sufficiently gotten to see all of the cool stuff that this soap and milk can make, did you expect that was going to happen? Because the first time I did this experiment, I did not think it was going to make this really cool and beautiful pattern. And it's a little bit weird, but we can actually figure out why this happened with the tools that I've already given you. So, something unique that you should know about soap is that soap has certain kinds of molecules, very special ingredients, that like both our blue category of molecule and our red category of molecule, right? So that's the cool thing about soap. And to kind of explain that a little bit better, because it's hard to visualize just hearing about it, I want you to open your jar back up and do a nice little squirt of dish soap into your jar. Again, make sure that cap is really, really nice and on tight. And I want you to shake it. Think back to how quickly the oil and the water separated. And is it separating this quickly now? For my end, it's not. It's still pretty cloudy. So the soap has a special ingredient that likes both the red kind of molecule and the blue kind of molecule. So it likes both the water and the oil or the fat. And so when you add the two together, they mix. Not like they usually do if you don't have the soap. And so what happened here is that when I added the soap onto the surface of the milk with our food coloring in it, it did two things. The first thing it did is it made the surface tension of the water not as strong. And so that let the molecules zoom and skate all over the surface. So adding dish soap was like turning your driveway into an ice rink, right? So you can ice skate around an ice rink, no problem. When we added the dish soap, that allowed the food coloring to zoom across the surface of the milk. The second thing that happened was the magic special ingredient in the soap that really liked the oil and the fat molecules also wanted to find the other oil and fat molecules. So what you're seeing is both the less surface tension, so the surface of the water wasn't as strong, and the like molecules, the category red category of molecules, are all trying to zoom around to find each other. And so that's why you're getting these really cool swirly patterns on the surface of your milk. And also, that is why you need to have soap and water when you're washing your hands. Because say I have dirt and gross things on my hands, and I have both the red category of molecules and the blue category of molecules on my hands. If I just run it underwater, I'm not going to get all of those molecules, all the gross stuff, off of my hands. And so that's why you need soap, which likes both kinds of molecules, to get off of your hands to clean them. That is all I've got for you guys today. Thank you so much for joining me. I had so much fun doing these science experiments with you all. If you have any ideas of other science experiments that you want to do, or if there are other science questions that you have, so why is the sky blue? Or I don't know, any other science question that you can think of, send it to me and let's see if we can work it out together and see if I can come up with a fun science experiment that you guys can do at home. And if you liked doing this and you want to see more, again, definitely let me know. Again, my name is Abby. I am a material science engineer with the Research Triangle Nanotechnology Network. I hope you guys have a great, fun, and safe day. Thank you so much for joining.